So as we introduce Six Sigma, it's important to talk about the cost of poor quality, probably the most important Six Sigma metric. Okay, so let's define quality first, though. Quality is when something serves its intended purpose and is without defects. Okay, so here's an example. You expect your phone to serve its purpose by being able to make calls, send text messages, surf the web, and you also expect it to work without defects. So when you call somebody, that it's the actual person you intended to call and not someone else. Okay, so something, we say it's of quality if it serves its purpose and is without defects. Now in Six Sigma, we talk about how it's important to first prevent defects, or we have an emphasis on preventing defects over fixing defects. We'd like to prevent something before it ever happens. And if we can prevent defects, it's more cost effective than having to fix them after the fact. Okay, so the cost of poor quality is the financial impact of our defects, probably the most important Six Sigma metric. It's the financial impact of these mistakes that we make in our products or services. And there's really four types of quality costs. The costs on the left here are good costs, and the costs on the right are bad costs, ones we try to avoid. Okay, so prevention costs are before production. Again, if we can prevent an issue or a defect before it occurs, that's ideal. Investments in prevention are good quality costs. And then there's appraisal costs, costs incurred during production. All right, we can expect those to happen, and they're necessary to hopefully avoid the quality costs on the right-hand side, the costs of poor quality. So internal failure is a defect that we identify after production finishes, but before we ship it to the customer. After production finishes, but before we ship it to the customer. And we can hopefully address it before we send it to them. So if we do introduce a defect, although we'd like to avoid it, if it does happen, we want to correct it before the shipment occurs. Now, an external failure is basically the worst case scenario. We've introduced a defect into our products or our services, and we've sent those to our customer. And then they oftentimes are going to complain or raise a concern, and we've got to address the issue after the fact. Those external failure costs are the most expensive and the most damaging to our brand and to our business. Okay, so now looking at those four types of quality costs, here's some examples of each of those. So prevention costs, again, those are before production. They could be things like contract reviews, supplier reviews, field tests, education and training. These things happen before production and hopefully prevent a defect from occurring. Appraisal costs, again, those are during production, and those are, again, necessary. Again, the costs, the types on the left-hand side here, those are costs of good quality. So these appraisal costs could be things like inspecting the product or process control measurements, so monitoring the process as it's occurring. And then the costs on the right-hand side, again, those are costs of poor quality. Like an internal failure, we introduce a defect, and we identify it after production, but before we ship it to the customer. And we often have to rework those products to repair them before they're ready to be sent out. External failure costs are defects we've introduced, and it becomes a big problem because we've sent the product to the service of the customer, and we've got to address it after the fact. So these could be things like recall costs, warranty claims, complaint investigations, legal penalties, and so on. They get to be very expensive when that occurs. Now, you may recall some time ago there were battery defects introduced in several Galaxy Note 7 phones, and Samsung lost a lot in external failures. They shipped a product to the customer that was defective, that had issues with it, and they had to pay a lot to address it. They would have liked to have prevented that before it ever happened. Now, having felt the pain, Samsung decided that they need to focus more on appraisal and prevention costs. So they've started this thing called Samsung's 8-point battery safety check to hopefully prevent this issue from occurring again. Now, it was estimated that the recall costs associated with this issue were about $5 billion. Now, but what this $5 billion number doesn't represent are things like lost future sales, lost customer loyalty, and damage to the brand. For the most part, that $5 billion was just to refund the customer for those phones. What could be even more expensive are these other things. And so in the cost of poor quality, we talk about this thing called the iceberg model. Okay, so there's visible costs or hard costs of quality, and also hidden costs or soft costs of poor quality. So visible costs are things like recalls, rework, and returns. Those things are visible and much easier to quantify. Now, the things that may even be a bigger problem, which are much more difficult to quantify, are things like lost future sales and loss to customer loyalty or damage to a brand. Those things can sometimes represent a larger portion of the overall cost, but they're much more difficult to quantify. So that's why we represent it through this iceberg model, because the smaller portion is on top, and there could be a much larger portion of the iceberg underneath. It's just more hidden. It's more difficult to quantify. Now, the question we should ask at this point is, why do we want to identify cost of poor quality at the start of our Lean Six Sigma project? Why do we think about this at the beginning? It's really because we need to know how bad our problem is. How much are we spending to address these issues? What's our opportunity there? And it's similar to triage at a hospital. Okay, it's similar to triage at a hospital. And we're really there to kind of find where we should and we can and should stop the bleeding first. Where is our biggest problem and what is the opportunity? What will happen if we improve this process?